Hello everyone, I am Someshri Senapati, Assistant Professor of Civil Engineering at Vedang Institute of Technology. So today in this class, we will discuss about degree of static indeterminacy. So previously in our classes, we have discussed what are the determinant structure and indeterminate structure and how to distinguish those. So we have already known the determinant and indeterminate structures. Now we will know the DS. What is DS? DS is nothing but your degree of static indeterminacy, that is denoted by DS. The formula for degree of static indeterminacy is total number of unknown minus total number of equation of equilibrium. Previously, we know that what is equation of equilibrium. Equation of equilibrium is nothing but all the forces acting in x direction must be 0, all the forces acting in y direction must be 0, and all the forces acting in z direction should be 0. If it follows this, so it means it is following equation of equilibrium. Okay, that means, so equation of equilibrium we can take by closing our eyes, that 3. Nothing to remember, just put 3 in case of number of equation of equilibrium is 3 always. So let's understand what is the number of unknown in case of, let's take it as beam. In case of beam, what is the number of unknown? So number of unknown is nothing but your reaction. So we know that when we discuss about a beam, we only have 3 supports, and for every support the reactions will be different. So here this one is your fixed support, another one is your pin, or you can say hinge support, pin or hinge support, and another one is your roller support. You can put it like this, also put it like this. This one is nothing but roller support. So here we have 3 types of support. So how to find out the reaction? So you need to remember these supports will control or will resist the forces in which direction. I can say here fixed support can resist the force in this side, in this side. Also it can resist the rotation. So in case of fixed support, the reaction is 3. In case of pin support, it will resist the forces from left, forces from upward or downward, but it cannot resist the rotation. So it has the reaction equals to 2. Next, the roller support, it can only resist the upward or downward force. So it has the reaction as 1. We need to remember these 3 things. Here in case of fixed support, R will be 3. In case of pin or hinge support, R will be 2. In case of roller support, R will be 1. If we just remember these things, now we can solve a lots of problems. Okay. So when we discuss about this degree of static indeterminacy, we have 2 things. One is your DSE and DSI. What are these? So DSE is externally statically and DSI is nothing but your internally statically determinate. So, as we are discussing about beam structure, we can just say it in case of beam, dsi will be 0, because in case of beam we don't have any loop. So in case of beam, dsi is your m minus loops. So in case of beam we don't have dsi, we just need to find out this dse. So what is this dse? Dse can be r minus e minus a. So now what are these r, e and a? R is nothing but, we have discussed now, that the reaction. The reaction we can calculate from the supports. Next is E. E will be always 3, that is your equation of equilibrium. Next is your A. What is this? This is nothing but the additional internal hinge. Additional internal hinge support. You can take the screenshot. So now this A will be, what is this? A will be nothing but your m dash minus 1. We will discuss this A thing in our numericals. Let's go for it. We have 3 numericals here. Let's first one. Here you have a pin support and here also pin support. So from this we can have the reactions like, we have to find out what? ds. To find out ds, we need to calculate dse, that is r minus e minus a. Let's write it here. R minus e minus a, that is ds and also dse. Okay. So let's write r equals to, as we are just solving it first, let's name it 1, 2, 3, 4. Here 4 number of reaction is acting. Now what is E? E equals to your 3. Let's understand how to find out the A. A is nothing but m dash minus 1. What is m dash? You can see here one internal hinge acting and I am taking it as A1. Also you can see here another internal hinge, that is A2. Let's find out first A1. The members connected with each internal hinge will be calculated. So here to this A1, the number of members connected is this and this. So in m dash place we will put 2 minus 1 equals to 1. Again in A2 case we have 2 members, this one plus this one. So A2 also 2 minus 1 equals to 1. Now from this we have that A equals to A1 plus A2, that is 2. So this R minus E minus A is going to be 4 minus 3 minus what? 2. That is equals to 1 minus 2, that is minus 1. So I can write here that ds is equals to minus 1. Okay. So now we will understand this. If this is minus 1, this is 0 and what? So what is the value going to be? we need to remember a few things before going to solve this ds. If ds is less than 0 or in minus, the structure is going to be unstable. If ds is equal to 0, you can say the structure is going to be just stable, and you can say just rigid. If ds is greater than 0, so the structure is overstable, or you can say over rigid. We know need to just remember these three things. Now we can put here. Here we have ds equals to -1. So the structure is unstable. Okay. Now we have a normal structure. Here you can see the fixed one. So the reaction will be here 3, R equals to 3, and here in case of pin joint we have 2. So here is R equals to 2. So the R will be 3 plus 2, that is 5. We know that E equals to 3. You can see there is no hinge support, so A will be automatically 0. Now R minus E is equal to your ds. ds will be 2. So the structure will be, I can say, overstable. Now here you can see this structure is roller structure, so it will have only one reaction, and in case of pin support it has two reaction. R equals to 1 here, and here R equals to 2, and you can see we have one hinge. So R will be 1 plus 2, that is 3. E equals to 3. A will be m dash minus 1, that is the members are 1, 2. 2 minus 1, that is 1. So 3 minus 3 minus 1, that is minus 1, and I can say D is equals to minus 1, that is the structure is unstable. Okay. Let's understand some more questions. Here we have 3 supports. You can see first one is your fixed support. So it has 3 reaction. Here this one is your roller support, so 1 reaction. And here you can see okay. Let's put one hinge here. Let's put 2 hinges here. So let's solve it. This R will be here 3 plus 1 4 plus 3 7. So E will be 3 and A1 will be m dash minus 1, that is 2 minus 1 is 1. A is your 2. So the R minus E minus A, that is here we are having a overstable beam. Okay. So this one we have one fix, another fix, and here you can see here 4 supports are there. So if one is missing, so you will get the wrong answer and the support will like collapse. Here 3 plus 3 6 plus 3 9 1, that is your 10. E will be 3 and A will be 1 2. 2 minus 1, that is 1. Here also the DS is 6, that is more or over stable. Okay. Here you can see 1, 2, 3, 4, 5. We have 5 supports. So in case of roller, we will have R equals to 1, 1, R will be 2, here 3. First we need to just check what are the number of reaction from the type of support. We only have 3 types of support, so we can remember the reaction for each support. 1, 1, 2, 2, 4, 3, 3, 6. We have 10 number of reaction. E will be 3. Okay, there will be no hint. So, A will be 0, R minus E minus A. The structure is overstable. Okay, so we are solving more and more number of numerical because we can be a pro in this section. If we are solving beam, so in our next class we can solve cross problems. So you can solve and enjoy this type of numerical. So I have lots and lots of numericals here. So here this reaction will be 1. This will be also 1. Here you have 2, have 3. 1, 1, 2, 2, 4, 3, 7. So you can here have A, that is m dash minus 1, okay. In this cases R is 3, here also R is 3. So we have the reaction as 6. You have one hinge, so A will be 2 minus 1, that is 1. 6 minus 3 minus 1, that is 2. DS is your 2. If the structure is overstable, so it is safe to construct. So that's why we have lots of overstable examples. Here we have pin support, that R is 2. Here R will be 1. Here R will be 2. This is 2 minus 1 is 1. So we can have ds is 1. Okay. Here this is your pin support. Three, 1, 4, 6, 8 and 10, and E is equals to 3. A will be okay. So we have solved 10 type of numerical and we have found out the structure is a stable one, a overstable one and non-stable one. So I have solved here all the types of beam we can have in our examples. Okay. If you have any doubt or any type of beam that I have never not solved, you can put it comment box. In our next class, we will discuss about truss and we will solve lots of numerical of truss. Thank you.